Hey, Assalamu alaikum. In this video, we will understand about the Sappanone A. So, what is the Sappanone A? And basically, it is a naturally occurring compound, Sappanone A. And the Sappanone A will extract from the Castelia Sapon L plant. So, Sappanone A is a naturally PDE4 inhibitor, the phosphodiesterase enzyme 4 inhibitor, which dual character anti-inflammatory and antioxidant activities from the heartwood of Castelia Sapon L. So in this way, this is the chemical formula of the Sappan A. So on the other hand, important thing is that the Sappanone A is the promising therapeutic agent to prevent. So it is to prevent the chronic obstructive pulmonary disorder, for short COPD, and inflammation. The present study predicted and validated that Sappanone A was a promising PDE4 inhibitor from SUMO with dual anti-inflammatory and antioxidant activities from SUMO. So what is the SUMO? SUMO is the Chinese medicine. So Sappanone A induces the NRF2 activation. What is the NRF2? We will discuss in the separate video, but you can understand that. So via the P38 MAP kinase pathway, the mechanism explains the anti-inflammatory effect of Sappanone A. So Sappanone A induces the NRF2 activation via the P38 MAP kinase protein pathway. The mechanism explains the anti-inflammatory effect of Sappanone A. We will discuss in this video here. So please watch the whole video to understand. So the Sappanone A supplementation will clear the inflammation and the oxidative stress because it is the antioxidant. So for example, the smoking cigarette will lead to increase the chain smoker due to the addictive substance nicotine. So whenever you will smoke, so your inflammatory mediators from the smoke will enter into the lungs, will activate the neutrophil, macrophage, and the epithelial cell. Epithelial cell activate the NADPH oxidase 2, NOx2. This NOx2 will activate the superoxide. This superoxide dismutase enzyme will convert into the hydrogen peroxide. So this hydrogen peroxide in the presence of metal ion complexing agent will lead to convert the hydroxyl ion. This hydroxyl free radical basically activate the oxidative stress due to the lactoperoxidase and the malondiandehyde A MDA. So the GSH and superoxide dismutase will decline. So it will decrease. So in this way, on the other hand, the necrotic factor kappa B will release from the macrophage by the activation and scavenging of the bad material, the inflammatory mediators from the cigarette smoke, lead to chronic obstructive pulmonary disorder due to the allergic reaction. While on the other hand, the PDE4 when increased will inhibit the cyclic AMP, protein kinase A, and CRAB protein. CRAB protein is important and it is responsible for the increase the inflammatory tumor necrosis factor alpha and interleukin 8 and MMP 9 and interleukin 10 will decrease. By this activation will lead to cause inflammation, and this inflammation will lead to activate again the LPO and MDA, while inhibit the superoxide dismutase will lead to more and more reactive oxygen species, lead to cause oxidative stress. So in this way, the tumor necrosis factor alpha and interleukin 8 and MMP 9 and interleukin 10 will lead to activate the oxidative stress stressing agent the GSH and SOD, the superoxide dismutase, decrease while the LPO and MDA will increase. Inflammation will occur by these agents, the tumor necrosis factor alpha, the cytokines, and interleukin 8 and MMP9 and interleukin 10 even decrease will lead to cause more inflammation. This inflammation and oxidative stress cycle occur in the lungs will lead to cause chronic obstructive pulmonary disorder. This chronic obstructive pulmonary disorder will lead to constrict the airway. In this way, our airway require the relaxation. So the Sappanone A will target to the phosphodiesterase 4 enzyme inhibition. In this way, the cyclic AMP will increase while the cyclic AMP will decrease when the PDE4 increase. So the Sappanone A inhibitor of the PDE4, while the Sappanone A also inhibit the inflammatory mediators. The SIRT1, mTOR and AKT and PI3K pathway will activate due to the LPO and MDA will lead to an increase the necrosis factor kappa B to increase the COPD. So on the other hand, the tumor necrosis factor alpha and tumor necrosis factor R1 and TRAD2 and the RID and the TAC1 and IKK will lead to increase the necrosis factor kappa B. So in this way, if you think about that, the PDE4 inhibition, how it is possible through the Sappanone. So first of all, you should need to understand what is the function of the PDE4. So the phosphodiesterase enzyme 4 will basically inhibit the cyclic AMP, and whenever it will inhibit the cyclic AMP, so in this way the cascade of phosphorylation will be stopped. So here is the G-coupled protein receptor will activate the intracellular trimeric protein to convert the GTP to the GMP, and the GMP will convert into the cyclic AMP due to the adenylyl cyclase enzyme. So the cyclic AMP will trigger the protein kinase A, but the phosphodiesterase enzyme 4 will lead to convert the cyclic AMP into the 5-AMP, and in this way the cascade of phosphorylation will not occur and NRF2 will not trigger and not phosphorylate. So MAP kinase and the mTORC will activate the NRF2 will lead to increase the HO1, and this HO1 will inhibit the reactive oxygen species. By this activation, the cyclic AMP increase due to the PDE4 inhibitor from the Sappanone A. So in this way, the NRF2 will increase, will lead to HO1 increase, and this HO1 increase lead to inhibit the ROS, so reactive oxygen species. In this case, the PDE4 inhibition will occur. While the vasodilation is very important in the bronchi, in the bronchi, so the vasodilation due to the PDE4 inhibit by the Sappanone A lead to cause nitric oxide production, lead to vasodilation. In this way, the airway will be dilate, lead to decrease the chronic obstructive pulmonary disorder.